So one place you'll really notice the effect of wind erosion is at a sand dune, and this is a really big one right behind me. Wind can really only pick up grains about sand size or smaller, so you're really going to see its effect where you have a lot of sand or small sediment. Now sand dunes have a steep side and a shallow side. And you can tell by the way the wind is blowing, by the way my hair is blowing, that that is the wind direction. So the shallow side of the dune is the direction the wind is coming from. The steep side of the dune is the leeward side. So what happens is every day the wind blows sand off the shallow side and deposits it onto the steeper side. So over a long period of time, weeks, even months, the dunes appear to slowly move down the shoreline because of this erosion on one side and the deposition on the other. And we call that dune migration. In fact, these specific dunes are called the walking dunes because over the course of a year they will appear to slowly migrate their way down the shoreline. The wind erosion can be destructive when it picks up smaller sediments. Wind isn't really strong enough to pick up anything larger than a sand grain, but if you throw sand against something continually, it can do a fair amount of damage, as you can see with what I think was once a set of steps over here. I mean, they seem to be made up of cement, some sort of man-made conglomerate, and even some metamorphic rocks. But because we're on the beach, this constant sea breeze blowing the sand against the side of this has turned it into more of a pile of stuff as opposed to an actual set of stairs. Hey, that is a nice piece of schist. So when waves come into the beach, they never come in straight. They're always coming in at a slight angle. And what happens then is you create this general direction of the water parallel to the beach. And those waves are also going to be carrying sediment. Now you can feel that sediment as it gets sucked up. If you stand right at the edge of the water, and as the wave goes out, it's like you feel like the sand's getting pulled out from underneath your feet. Well, it really is. So what it's doing is it's carrying it down the beach, and this is called longshore drift. So to prevent the erosion of the beaches, we build these things called jetties or groins. Now you can really see how one side of this jetty, the beach goes all the way out to the end. And that's the side where the sediment is being deposited because the waves lose energy as they hit the jetty, and they're going to drop what they're carrying. The opposite side of the jetty, that's not where the waves are hitting, so the beach remains fairly far back. And this is really helpful because now the sand, instead of being carried all the way out and washed away Long Island, is actually being maintained at the shoreline. Now since waves are also moving water, any sediments they're carrying are going to undergo abrasion just like in a stream. And what that means is that the sediments, as they're carried, bang into each other and break off all of the sharp edges, which is why you get these nice round smooth sediments at shorelines. That's also how you get that nice smooth sea glass that people talk about. Again, it's just an abrasion process. So the beautiful sandy beaches that you see here on the south shore of Long Island, these are all outwash plains. Outwash means that the actual glacial deposits are north of us, but when the glaciers melted, they washed all the sediments toward this south shore area, and they sorted them and rounded them and made them nice, beautiful sandy beaches like we have here on the south shore of Long Island at Jones Beach. And wow, am I getting wet. The north shore, however, is very different. Here you have pebbles and cobbles and other large sediments because this is an outwash. This is direct glacial deposit. We are on the north side of the terminal moraine, which is why we get these very cobbly beaches.